Hello. In this video, we're going to take a look at a couple more examples for using integration by parts. So we want to find the integral of arctangent of y. Using that mnemonic ILATE, I stands for inverse trig. We have inverse trig here, tangent inverse of y. ILATE tells us what to pick for u. So u is going to equal tangent inverse. dy or dv is going to equal everything else, which is dy. Remember our integration by parts formula? We need to find the integral of dv, which the integral of dv is b equals y. And we need to find the derivative of tangent inverse. We're picking this because tangent inverse is a derivative we know. The derivative of tangent inverse, or arctangent, is 1 over 1 plus y squared. Filling in the formula, u times v is y times tangent inverse of y minus the integral of v times du. Y times 1 over 1 plus y squared dy. Integrating this piece requires a u sub. When we have integration by parts and u sub together in the same problem, very good idea to use a different variable, either for the u in integration by parts or the u in the u sub. But we've already used the u for integration by parts, so I'm going to pick a different variable. I'll pick t to make our u sub. T equals that denominator, 1 plus y squared, dt equals 2y dt, or 2y dy, or 1/2 dt equals y dy. Making this now, keeping the old part that we already know, minus, rewriting our integral in terms of t, we will have 1/2 the integral of 1 over t dt. 1 over t is the natural log of t, natural log of the absolute value. Natural log of the absolute value of t plus c. And plugging t equals 1 plus y squared back in, we have our antiderivative of arctangent. Now, looking at another example, e to the x sine x integral. We pick u using ILATE, and we are going to fill in the formula. U dv is equal to u times v minus the integral of v du. Now, the two things at the bottom here, trig and exponential, they're at the bottom because they're very cyclic. Like the integral of e to the x is e to the x, and the derivative of e to the x is e to the x. The derivative of sine is cosine, and the derivative of cosine is negative sine. Just get these cycles going. So in this problem, well, we're going to still use it to pick our u, because these are so repetitive, we could actually pick either one and still get to the same result. Using this specifically, it says pick trig over exponential. So I'm going to pick u equals sine x and dv equals e to the x dx. Taking the derivative of sine, we get cosine x. And taking the integral of dv, we get e to the x. So the integral of e to the x sine x is equal to u times v minus the integral of v du, e to the x cosine x dx. Now you might notice here, this is very similar to what we started with, a cosine instead of a sine. And that if we do integration by parts again, it's not going to make things simpler in terms of when we did things with algebraic expressions, we'd go from an x squared down to an x down to a constant. That's okay here still, and we'll see that in the next line. We're going to try the integration by parts again. We're going to use integration by parts on e to the x cosine x. Make u equal cosine x. Du equals negative sine x dx. dv equals e to the x dx again, and v equals e to the x. So applying integration by parts again, leaving the stuff we already know. Now, using integration by parts on the e to the x cosine x, we'll have e to the x cosine x minus the integral of negative e to the x sine x dx. Simplifying with some negatives, number one, this negative times this negative will become a positive. And then this negative will distribute to both pieces. So I'm going to distribute it to both pieces by turning this back into a negative and moving my parentheses. So we get e to the x sine x minus e to the x cosine x minus the integral of e to the x sine x dx. The thing we're trying to solve for appears in the equation. We can treat it like a variable. We can add the integral of e to the x sine x to both sides. And that is equal to e to the x sine x minus e to the x cosine x plus c, because there's no longer an integral on that side. But if 2 of this integral is equal to e to the x sine x minus e to the x cosine x plus c, we can divide by 2 and ultimately get that the integral of e to the x sine x dx is equal to 1/2, dividing everything by 2, e to the x sine x minus e to the x cosine x plus c. In the next video, we'll look at some more specific examples of some unique cases that might come up or how we can use these in application problems.